Welcome back. Today, we're going to do something a little different. We are putting a modern web application under the microscope, giving it a complete health check to see what really makes it tick. And our guide for this whole process? Well, it's the app's very own internal architecture report. All right, let's get into it.
So first things first, what kind of beast are we even dealing with here? This app is what's called a headless monolith, and it's a really cool setup. Just imagine you have a brain. That's the backend. It does all the heavy lifting, all the thinking, and manages all the data. Then you have a totally separate body, the front end, that just talks to the brain through an API to figure out, what to do and how to look. They're two separate things, but they work together perfectly as one unit.
So, here's our game plan for the checkup. First, we're going to look at the application's overall blueprint. Then, we'll dive into the anatomy of the system itself. After that, we'll trace how data moves through its, let's call it, a nervous system. And finally, we'll give our official diagnosis and write up a prescription for improvement.
All right, first up, the blueprint. Just like a doctor checks a patient's chart before an exam, we need to get a high-level overview. We've got to understand the basic structure we're working with before we go any deeper.
The key idea here is this thing called a monolithic monorepo. It sounds kind of techy, I know, but think of it like this. The back-end brain and the front-end face live together in the same house. That's the single code repository. But, and this is super important, they basically act like two totally independent roommates. They've got their own space, their own rules, but they just happen to share the same address.
Okay, so we've got the blueprint down. Now it's time to put on the surgical gloves. In this section, we're going to dissect the anatomy of the system and take a close look at the two main organs that make this whole thing work, the back end and the front end.
And this slide just lays it out so clearly. Over on the left, you have the brain, a powerhouse Laravel backend. Its one and only job is to handle all the logic and serve up data through an API. Then on the right, you've got the face, a sleek React front end. It's a single-page application, which means it feels super fast and responsive. Its job, to grab the data from the brain and make it look amazing for you, the user. Simple as that. One thinks, the other presents.
So how does the brain stay so organized? Well, it uses a really strict pattern, almost like a well-run hospital. The controllers? They're the receptionists. They just greet incoming requests and point them in the right direction. The services are the expert doctors. They hold all the important business logic and do the real work. And the repositories? They're like the librarians in the archives, in charge of fetching the exact data you need from the database. And they're smart enough to remember recent requests through caching to speed things up. This clear separation is absolutely crucial for keeping the code clean and easy to manage down the line.
And the front end is just as smart. It uses a clever structure of smart pages that are responsible for fetching data and dumb components whose only job is to display whatever data they're given. It makes the whole thing really predictable. It also manages its data, or state, in three very specific ways. For talking to the server, it uses a powerful library called React Query. For simple UI stuff, like if a drop-down menu is open, it just uses a basic useState hook. And for information that needs to be available everywhere, like who's currently logged in, it uses something called auth context. See? No over-engineering here, just the right tool for the right job.
Now for the really fascinating part. We've seen the individual organs, but how do they actually communicate? We're about to trace a signal as it travels through the app's nervous system. We're going to see exactly how these parts talk to each other to get things done.
The question seems pretty simple, right? But the answer reveals the entire architecture in motion. You click a button on the screen to view your garden logs. What happens in that split second? How does that single click travel all the way to the database and get information back to your screen?
It's like watching a beautifully choreographed dance. First, React Query on the front end kicks off the request. Then, a little helper called Axios packages it up and sends it across the network to the back end. Laravel's router acts like a traffic cop, directing the request to the exact right controller. That controller, being super efficient, immediately hands the job off to the correct service. The service then turns to the repository and says, "Hey, get me this data." And the repository cleverly checks its cache first to see if it can save a trip. Finally, the data is transformed, packaged up neatly into clean JSON, and sent right back to your screen. From click to data in 6 perfectly clear steps.
Now hold on, because that last step is the most important one. The backend doesn't just dump raw data from the database. No way. It uses something called an API resource. The best way to think about it is like a bouncer at a fancy club. It checks every single piece of data before it's allowed to leave, making sure it's formatted correctly and that no sensitive internal information like secret database IDs or something accidentally gets out. It is an absolutely critical layer for both security and just clean design.
All right. We've looked at the blueprint, we've examined the anatomy, and we've traced the nervous system. Now it is time for the final report, our official diagnosis of the system's health, and our prescription for keeping it in peak condition. And I've got to say, the diagnosis starts with some really good news. This application is in great shape. The report clearly shows it's following a whole bunch of industry best practices, which tells us it's a well-thought-out and seriously robust system.
I mean, just look at this clean bill of health. We see that strict service repository pattern we talked about, check. Dependency injection, which is just a fancy way of saying components are more flexible and testable, check. Those super important API resources, check. It's even using advanced techniques correctly. Things like generators, which is a clever way to handle large amounts of data without crashing, and atomic locks, which prevent chaos when lots of people try to do the same thing at once. This isn't just good code. This shows a real commitment to quality.
But, of course, no system is ever 100% perfect. The checkup did flag a few minor things. In the back end, some of the search logic is a little tangled, and there's a duplicate documentation file that could cause confusion. On the front end, some table layouts are hard-coded, making them a bit rigid, and there's a small configuration issue with an API address. Look, these aren't critical illnesses, they're more like small bits of technical debt that should be addressed to prevent future headaches.
So with that diagnosis in hand, the report gives us a crystal-clear, actionable prescription for what to do next. This isn't just a list of complaints, it's a prioritized roadmap to make this already healthy application even better.
And here it is. Top priority is just some simple housekeeping. Get rid of that duplicate documentation. Easy win. Next, at medium priority, clean up that front-end code by making the table definitions more flexible and publish a config file to make the search feature easier to tweak. And finally, a low priority task. Just do a quick code review to make sure everything is as strict and tidy as it can be. It's a simple, effective, and totally manageable treatment plan.
And all of this leaves us with one final big picture thought. We all chase this idea of the perfect code base, don't we? But maybe that's a myth. Maybe the true sign of a healthy, mature, and professional application isn't that it has zero flaws, but that it has a process, a continuous cycle of building, diagnosing, and improving. What do you think?